The title of the presentation is Slow Pyrolysis of Durio zibethinus rind and the Influence of Carbonization Temperature on Biochar Properties. My name is Anurita Selvarajoo. I am from Department of Chemical and Environmental Engineering, Faculty of Science and Engineering, Nottingham University, Malaysia campus. I am dividing my presentation into Introduction, Methodology, Results and Discussion, and finally the conclusions. The depletion of fossil fuel is creating awareness of the need for a sustainable future, and interest in alternative energy sources has increased tremendously in recent years. Pyrolysis is one of the efficient thermochemical methods to convert biomass to valuable products like biochar, bio-oil, and syngas. The aim of this work is to study the optimum operating pyrolysis conditions like temperature and holding time to produce biochar. In Malaysia, around 3,800 metric tons of durian fruits were produced in year 2016, and around 60% of it are the husk, approximately 2,280 metric tons. The large quantity of durian rinds represents not only significant disposal problems, but also tremendous waste of resources that could be upgraded into something valuable. Let us look into the methodology of the pyrolysis process to produce biochar. First, the biomass or the durian rinds are air dried. The air dried rinds are then ground to 1 to 2 mm size. The ground air-dried samples are then subjected to pyrolysis experiment in a tubular furnace. Then we have biochar after the pyrolysis, which are subjected to thermogravimetric analyzer for TGA analysis. And the raw material or the air-dried durian rinds and the biochar are subjected to bomb calorimeter where heating value is being determined. The operating parameters that are being studied for these studies are temperature of 300, 500 and 700 degrees Celsius, the dwelling time or the residence time of 0 to 3 hours, the heating rate is 5 degrees per minute. This shows the results and discussion. This table shows the proximate and ultimate analysis of the air-dried durian rind. So we can see the moisture content of the durian rind is around 8.69%, volatile matter of around 82.47%, ash content of around 3.08%, and finally the fixed carbon is around 5.76%. For the ultimate analysis, the carbon content is around 40.47%, nitrogen content of around 0.82%, hydrogen of 5.47%, and finally the oxygen content is around 53.24%. The figure over here shows the effect of temperature and also the effect of holding time on the yield of biochar and also the heating value. From the figure 1a, we can see that the optimum temperature to obtain a high yield of biochar, which is around 39.6% weight with a heating value of 29.75 megajoule per kg, was at 325 degrees Celsius. Then the holding time were investigated, and it shows that at 120 minutes the biochar yield of 40.8% is obtained with a heating value of 28.7 megajoule per kg. So this shows that we only need an operating hour of 2 hours to obtain a good yield and also a good heating value of biochar. This figure 2 shows first A, the TG curve, followed by V, the DTG curve. So we can see at the first stage of the weight loss occur when the sample is heated from room temperature to a temperature of around 110 degrees Celsius. This accounts to the loss of moisture of the sample. The second stage, on the other hand, showed one observable peak. The mass loss rate of biochar was at 1.44 milligram per minute at 300 degrees Celsius. This is the highest peak that is being reached. Then continuous weight loss from 350 to 920 degrees Celsius is observed, and the total weight loss at this stage for durian rain was 86.21%. In the active zone, the main decomposition happened for hemicellulose together with cellulose, which attribute to the release of volatile compounds. In the passive zone, lignin and cellulose decompose and contribute to high volatile compound that is being released. As a conclusion, we can conclude that major parameters that influence the biochar from durian rain are temperature and holding time of the sample. Pyrolysis temperature of 325 degrees Celsius and holding time of 2 hours was found to be the optimum condition to obtain a high heating value of biochar, which is 28.7 megajoule per kg and 40.8% of biochar yield. The biochar obtained from pyrolysis can be a good feedstock for other thermochemical conversion like gasification. I conclude my presentation. Thank you.